Today, we will be looking at how to expand the binomial a plus b raised to power 5. But in this video, we'll be using the Pascal's triangle. We will be using the Pascal's triangle to expand the binomial a plus b, all raised to power 5. So it's good to understand that we'll be obtaining the coefficients of the binomial expansion using 1, the Pascal's triangle, and then 2, the combination formula n combination r. But as we had earlier mentioned, for the purpose of this video, we will be using the Pascal's triangle in order to obtain the coefficients of the binomial expansion. So let's quickly have a recap where you have one term, that is one algebraic expression. In this case, for example, 3y, we call it a monomial. In the scenario where you have two terms, in this particular case, 3y and then plus 7, we have a binomial. We have a trinomial when we have 3 components. We have the 3y, 2z, and 7 in this particular example. Now, when we have a plus b, just like we said, we have a binomial expression when we have two terms. We have an a and we have a plus b. As you can clearly see, we have a and we have b. Now, when we are raising it to the power of n, then it comes with an expansion. And in this particular video, we intend to express a plus b all raised to power 5. And that becomes a binomial expansion. Binomial because we have a and then we have a b, and then an expansion because we are raising it to the power of n. N in this particular case is equals to 5. We will be looking at the Pascal's triangle, and you can see we have row 0 and we have a 1. Let's look on the right hand side. We now have a 1 and a 1. And then now for row 2, we have a 1, 2, and 1. Notice that your 2 is simply obtained by adding this 1 to this other 1. And that's how we continue to get the subsequent terms. We get the subsequent terms by adding the preceding terms. Now, if you look at row 3, you have a 1 on the left-hand side. So notice the pattern. It always starts with a 1 and ends with a 1. And then the middle terms are obtained by adding the terms on top. Like, for instance, this 3 is simply obtained by adding 1 and 2. And notice like this other 3 here is obtained by adding the 2 and 1 above. If we move to row 4, like I said, the first and last terms are always 1. The first and last terms are 1. And then the middle terms are obtained by adding the terms on top together to get the middle term. Now this 4, how did we get 4? We added 1 above and then 3. How did we get 6? How did we get 6? We added the 3 above and the 3 above. So 3 plus 3 is 6. Now, how are we going to get the 4 here? How did we get the 4? We added the 3 above and the 1 above. So can we pause the video for 1 second and then know how or anticipate what we'll get for row 5 below? Your guess is as good as mine. What we anticipate to get is 1, and then 4 plus 1 plus 4 is 5. So 1, 5. Then 4 plus 6 is 10. So we have a 10. And then 6 plus 4 is 10. So we have another 10. And then 4 plus 1 is 5. So we have another 5. And then at the end, we have a 1. Let's see whether that's what happens. Yes, your guess is as good as mine. So we've clearly shown how we get the terms and how we start with the 1 and end with the 1. And then the middle terms are obtained by adding the top terms together, as we have clearly seen. So this is very simple. We do not need to cram this. All we need to do is just to understand how this is formed. So this is what we call the Pascal's triangle, and it is from this triangle we are able to get the coefficients of our binomial expansion. From this Pascal's triangle, we are able to get the coefficients of a binomial expansion. Now, take note of row 2 and also take note of row 3. Take note of row 2 and also take note of row 3, because we'll be using an example as we go along. Let's consider the binomial expression A plus B. Let's consider the binomial expression A plus B. Now we are raising both of them, A plus B, raising it to the power of n, thereby making it now a binomial expansion. Now when n is 2 or n is 3, we have considerations. Now when n is 2, we look at row 2 of the Pascal's triangle. And when we look at row 2, if you look at the right-hand side, you have the coefficients 1, 2, and 1. And when you have n is equals to 3, that is when the power is equals to 3, we look at the row 3 of the Pascal's triangle. And we have 1, 3, 3, and 1 on the right-hand side above as the coefficients. Now let's consider an example when n is equals to 2. That is, a plus b is raised to power 2. N is 2. And that implies, if we look at the coefficients, we have 1, 2, and 1. And if we look at n is equals to 2 above, which is row 2, it corresponds to 1 at the top right, 2, and 1. So we had mentioned it earlier that the Pascal's triangle is used to extract or obtain the coefficients of the binomial expansion for a given n. And when n is 2, we look at row 2. And then when we look at row 2, we're able to get the coefficients, which is 1, 2, 1. And that corresponds with 1, 2, and 1, as we can clearly see. Now, let's look at the a component, a, and then let's look at also this power n, which is 2. So we'll start our a raised to the power of 2. And then when we move to the next, it now becomes a raised to the power 1. That is from 2 to 1. And then here it becomes 0. So here from a raised to the power 2, then a raised to the power 1, and then a raised to the power 0. So reduces 2, 1, and then 0. Now, if we look at our second value, which is b, b is raised to the power of 0. And then when it comes here, raised to the power of 1, and then it's raised to the power of 2. Now, b raised to the power of 0, b raised to the power 1, and b raised to the power 2. So from 0 to 1 and then to 2. Now, notice that a here is raised to the power 2. And notice that b here is raised to the power of 0. If you add their powers, that is 2 and 0, it gives you the n value here. 2 plus 0 is 2. Now, if we look at this consideration also, the power of a here is 1, and the power of b here is 1. 1 plus 1 gives you 2. If you look at this third component, the power of a here is 0, and the power of b is 2. 0 plus 2 gives you 2, and that corresponds with n is equals to 2. So that's what we have for a simple binomial expansion when n is equals to 2. And when we simplify that, we have a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. Now, if we look at n is equals to 3, what we have in the binomial expansion is as shown. Now, let's look above where n is equals to 3. N is equals to 3. It implies that we look at row 3 in the Pascal's triangle, which corresponds with 1, 3, 3, and 1 for the coefficients. When n is 3, our coefficients are 1, 3, 3, and 1, as we have clearly seen. Now, for the a component, which is the term here, we'll raise it to the power of 3. And then as we go to the right, it becomes a raised to the power 2, then a raised to the power 1, and finally a raised to the power 0. So it starts with n is equals to 3 and reduces to n is to the power of 0. So a raised to the power 3, a raised to the power 2, a raised to the power 1, and then a raised to the power 0. Now let's consider the b component. So here it's b raised to the power 0, b raised to the power 1, b raised to the power 2, and then b raised to the power 3. That is from 0, power of 1, power of 2, power of 3. Now, notice that the power of 3 and the power of 0, when you add both of them, 3 plus 0 will give you the value of n. To give you the value of n. And n is equals to 3. Now, if you consider the second part also, the power of 2 here and the power of 1, 2 plus 1 will always give you the power of n. Same with this component here, a raised to the power 1 and b raised to the power 2. The 1 here plus the 2 here, which is 3, will give you what n is. And similarly here, 0 plus 3 will give you 3. So that's a simple consideration. Now, when we simplify this, a plus b all raised to power 3 is a raised to power 3 plus 3a squared b plus 3ab squared plus b cubed. So now we'll be solving the actual question of the day. And that question is simply a plus b all raised to the power of 5. And we've seen some previous examples. And so that should make this very clear, where our solution is as shown. As we go along, we notice that the sum of the powers of a and b add up to 5. The sum of the powers of a and b add up to 5. Now, the coefficients in red, we will be obtaining them from the Pascal's triangle. And since our power is 5, that is a plus b is raised to the power of 5, we'll be looking at row 5 in the Pascal's triangle. We will be looking at row 5 in the Pascal's triangle for the coefficients. We'll be looking at row 5 in the Pascal's triangle for the coefficients. And as we can clearly see, our coefficients in the Pascal's triangle include 1, 5, 10, 10, 5, and 1. We have our 1, 5, 10, 10, 5, and 1, as we have incorporated above. Now, our a components raised to the power 5, because n is 5, and then it reduces to a raised to the power 4, and then a raised to the power 3, a raised to the power of 2, a raised to the power of 1, until we get a raised to the power of 0. Now, for the b component, we have b raised to the power 0, and then it increases to b raised to the power 1, b raised to the power of 2, b raised to the power of 3, b raised to the power of 4, until we get to b raised to the power of n, and n is 5, that is b raised to the power of 5. Now, as I earlier mentioned, if you notice the powers of a and b, in this first case 5 and 0, and you sum them, 5 plus 0 is 5, and that equals to what our n value is. And that applies here. 4 plus 1, 5, 3 plus 2, 5, 2 plus 3, 5, 1 plus 4, 5, and then 0 plus 5, which is equals to 5. Let's consider our a plus b, everything raised to the power n. You will have n plus 1 terms. You will have n plus 1 terms. Now, for a plus b, everything raised to the power 5, since our n is 5, we'll have 5 plus 1 terms, that is 6 terms. Whatever the power is, by the time you add 1, that gives you the number of terms. So we have a plus b raised to the power 5. Our power here is 5. Therefore, we will have 6 components of our expansion. So this is 1. This is 2. This is 3. This is 4. This is 5. And this is 6. So you will always have n plus 1 terms for your given expansion. So let's simplify a plus b all raised to the power 5. We have a raised to the power 5 plus 5a raised to the power 4b plus 10a cubed b squared plus 10a squared b raised to the power 3 plus 5a b raised to the power 4 plus b raised to the power 5. So that is the simplification of our question, which is a plus b all raised to the power of 5. Thank you. Kindly subscribe, like, and share if you have obtained any value.